Hi, Geometry. This is 12.6. This is actually the last section in this chapter. So make sure you look over that chapter review and go back and review questions that are on all of these sections so you can figure out your test, because your test is going to be doing this entire chapter review. There are 50 questions, so that means there were 2 points each. You can get at least a 50, but I want to see the work. If I just see an answer like 20 degrees south of east without any diagrams, any Pythagorean theorem, you will not get credit for that because the answers are in the book. Now, most of you are not drawing triangles. They are absolutely necessary for most of this work. You have to be a genius not to draw the triangles, and so please don't try to snow me. All right. Law of sines and law of cosines are for finding parts of triangles that are not right triangles. If they are a right triangle, you can use sines, cosines, and tangents to find missing parts. Okay? As long as one of those angles is 90 degrees, you can just use regular old sine equals opposite over hypotenuse, tangent equals opposite over adjacent, cosine equals adjacent over hypotenuse to find missing parts. Okay? However, not all triangles are right triangles. So we have something called the law of sines and the law of cosines, where you can use the sines and cosines on your calculator to solve for missing parts. The law of sines you can use when you're able to find an angle side pair, or you're given an angle side pair. For example, if they give you angle C and side C, then you can use the law of sines to find, and then you have to have one of the others, like angle A or something. Then you can use this ratio. The side across from angle A divided by the sine of A equals the side across from angle B divided by the sine of B. So you only use 2 at a time. You don't have an equation with 3 going across. So once you do this and find B, then you can do that and find C. And I'm going to do an example. The law of cosines is when you are given 3 sides, or you just don't have one of those angle side pairs. So that is always the side you're looking for equals the other 2 sides squared. See, it looks a little like the Pythagorean theorem, b squared plus c squared, minus 2bc times the cosine of the angle across from the side you're looking for. Sometimes you might be looking for an angle and you have all 3 sides, then this side should be across from the angle you're looking for. So you don't have to memorize a bunch of different equations. Just remember this goes across from the angle you're going to use the cosine. The other 2 sides are B and C. So let's take a look. It says find A in triangle ABC if angle A is 57, B is 6, and C is 9. Now most of you right away start to panic because there's no triangle. Draw the triangle. It doesn't even matter if you draw it pretty. Just label it correctly. So you can just go, there's a triangle. Label it, A, B, C. Angle A is 57. B, which is the side across from B, is 6. C, which is the side, is 9. Okay? And so if you look, I don't have the side across from the angle, so I can't use the law of sines. But I can use the law of cosines. So if I'm looking for A, which is the side across from angle A, I can just use this formula. A equals, pick either of these 2 sides to be, well, let's use B, 6 squared plus 9 squared minus 2 times 6 times 9 times the cosine of 57 degrees. And then if you do that carefully on your calculator, you just get your answer. So you can just roll it along. You can say 6 squared plus 9 squared minus 2 times 6 times 9 times cosine of 57. And you come out with, sorry, that should be A squared. Sorry, had a long drive yesterday. So you come out with A squared is 58.18. And then you get the square root of that, and you get 7.63. Okay, now, why did I know that I had forgotten to put the square? This is something you should think about. If one side is 6 and one side is 9, does it make sense the other side would be 58.18? So the second I got that answer, I realized I had written the formula wrong. So start thinking logically like that and checking and catching your own mistakes. Don't just blindly put down something that's ridiculous. All right, so that's how you use the law of cosines. Now the law of sines, here's an equation. Here's one that says find B if angle B is 71, angle C is 52, and C is 6. All right, so draw your triangle, label it ABC, and B is 71, C is 52, C is 6. So this is A and this is B. Now if it's just asking for B, we just have to do, we have a pair. Where do we have a pair? C is 6. I made that 6 look like a B. All right, so we have a pair. So we can say 6 over the sine of 52 is equal to A over, we don't want to find A, we want to find B. B over the sine of 71 degrees. Then you do what? Cross multiply. 6 times the sine of 71 degrees equals B times the sine of 52. And you can now just do this on your calculator. You can solve it first before you start punching in, or punch in this side, punch in sine of 52, and then divide. So you can do it both ways. I prefer, because I just like to just punch in once, I can say, well, I'm going to divide both sides by sine of 52. And then I can just punch 6 sine of 71 divided by sine of 52 in my calculator and get B. So 6 sine of 71, make sure you close those parentheses. I always hit equals before I divide, just to make sure. Sine of 52, close your parentheses, and I get 7.2. So B equals 7.2. I don't know if you can see this on the, I kind of have it tilted up. Now, what if I had gone to find A? Well, I could have just added these two together and subtracted from 180 and found A first, and then I could say A over the sine of A. So there's no reason why you couldn't find it, because you know once you have two angles of a triangle, you can get the third angle by subtracting those two by 180, from 180. Thank you.